Good morning, dear students. Today we are having eighth practical lesson. Our previous lesson was a differentiation of function of multiple variables, and today we will use. To our today lesson will be about application of function of several variables. So let's first of all, in the first task, find the equation of tangent plane and the normal to the surface P at point M. So 1a, we have the following function, z equals 2x square minus 4y square. And how to write down the equation of tangent plane. So the following formula. So dz by dx at point M. Just a moment. So at point M multiplied by x minus x m plus analogically. Yeah, so we have two cases. So the first case when the function is given explicitly. And plus z minus z m so equals 0. So this is the case when the function is given explicitly. When it's given implicitly, so when we have so f from x, y, and z. So, but z is the function that depends on x and y. So the formula looks a little bit in another way. So we change z to f, and for z analogically we do the following stuff. So we oh, so here must be 0 or must be minus. So df by dz here. So this is the equation of a tangent plane. And what about the normal? So the equation is the following. So again, at point M, so it looks like this. So normal is a straight line, as you remember. Yeah, let's do some copy and paste, and after that we will fix everything. Oh, stop. Y here, and here z minus zm, and minus 1 in the denominator. If the function is given explicitly. If implicitly, so analogically, so we change to f, so the derivative of this expression, and the same for z. So now let's use these formulas for our task.
Sorry, can I ask? The first formula is for explicitly and the next for implicitly, yes?
Yes, correct.
Thank you.
So let's calculate derivatives now, because we first of all we need to use them, and after that we will start using and after that we will write down the equations. So dz by dx at point M, so it will be equal 4x, yeah, at point M. Yeah, by the way, point M has coordinates 2, 1, 4. So it will be equal 8. So analogically to derivative by y, so we have minus 8y, and it will be equal minus 8. So let's write down the equation of the tangent plane. By the way, which of them we will use for implicit, for explicit, or for implicit? Okay, let me help you. So actually, the function is given explicitly, so z depending on x and y. So we will use this formula. So the equation of tangent plane is the following. So 8 by x minus 2 minus 8 by y minus 1 and minus z minus 4 equals 0. We can expand brackets and so on, but let we not do it for now. So just arithmetic stuff. And for tangent, and for the normal equation, so we do the following stuff. So we just, values of derivatives are coordinates of, so for the tangent plane, derivatives of point M are coordinates of normal vector. For the normal equation, they are equation of the direction vector. So it's done for the first task. Any questions for now?
No questions.
Okay, if no questions, let's move to task B. So we will have another kind of function. So now we have function z that dependent on xy, but it is given implicitly. So now, so we have actually this f from x, y, and z. So such expression, if so if we have some parts on the right side, we have to move everything to the left side. So we have such expression. So let's differentiate. So it will be equal 3x square plus yz at point M. So it will be equal. Yeah, by the way, point M has coordinates 1, 2, minus 1. So 3 minus 2, so equals 1. Then, analogically for y, so it will have so it will be 3y square plus xz at point M, and it will be equal, so 24 minus 1, 23. So yeah, and something is oh yeah. Oh, stop. Yeah, it will be 11. Yeah, I just confused degree a little bit. So not cube, but square. So 12 minus 1, yeah, it will be 11. And now differentiating by z. So 3z square plus xy. So it will be equal 3 plus 2, it will be equal 5. So found. And now let's write down the equation of the tangent plane. So uh, x minus 1 plus 11 y minus 2 plus 5 z plus 1 equals 0. So this is the tangent plane, plane. And what about the normal? So x minus 1 over 1 equals y minus 2 over 11 and equals z plus 1 over 5. So that's it. Any questions about this exercise?
I don't understand how we get the last equation.
This
Which
one.
is yes, and that is below or above, because where we get these coefficients.
These coefficients, they are coordinates of so okay, yeah, these coefficients are taken, so so values of the partial derivatives and at point M. So actually this is the normal vector for the tangent plane and direction vector for the normal straight line.
Yeah, thank you. I understand.
More questions? Okay, if no questions, let's move next. Then the following task. We have to find the derivative function at point M in a given direction. So to A, so the function is the following: logarithm of x square plus y square plus z square, and coordinates of the point M are the following: 1, 2, 1. So how to calculate, yeah, and the vector, by the way, vector R has coordinates, so 2, 2, 4, and 4. How to calculate the derivative by, so derivative in a given direction. So the following formula, du by dr, so at point M. So it will be equal, so the following stuff. So du by dx at point M, and multiplied by so no r. So the x coordinate of vector r by the magnitude of vector r. Plus analogically to y and z. So we will have such so we will have such values. So it is the scalar number. So let's calculate first of all derivatives. So du of dx at point M will be equal. So first of all, so differentiating this outer function and yeah, multiplied by 2x and everything at point M. So 1 to 1, so 6 at the denominator, so 2 over 6 equals 1 over 3. So found the derivative at point of by x. Now finding partial derivative by y. So actually what changes here only y. And then continue calculation. So 6 in the denominator, 4 in the numerator, so 2 over 3. And now calculating a partial derivative by z. Oh, stop. So 6 and here, so 2, so 1 over 3. So calculated partial derivatives, and now what do we have to find? Also there.
You forgot to change not to y, but maybe to z.
Yeah, thank you for your attention. So now everything is correct. Yeah, copy and paste in problem can cause a lot of problems, especially when programming. Yeah, so pay attention to it in the future. Well, so now we have to calculate the magnitude of vector R. So, so 4 plus 16 plus 16, so it will be equal square root of 36 and equals 6. So found the found coordinate. So now we can calculate the derivative in the direction of this vector. So first of all, 1 over 3 multiplied by 2 over 6 plus 2 over 3 multiplied by 4 over 6 and plus 1 over 3 multiplied by 4 over 6. So now let's simplify it a little bit. So here I will have, so 1 over 9 plus 4 over 9 and plus 2 over 9. So it will be equal 7 over 9. So calculated it. Any questions about this exercise? Okay, I guess that no questions. So now, yeah, actually so let's skip part B. Derivatives will be even simpler that in the task A. And what about the direction of the vector? Yeah, you will also have to calculate coordinates coordinates of the vector mn, but you will do it in your own as your home task. So it is easy. And now let's move to the task number 3. We will have to calculate the gradient of the function u. So that equals x cube by y square by z. So the point is so point M has coordinates 1, 1, and 1. What is actually the gradient? So we have different symbols to mark the gradient. So operator nabla or just this so grad u. Actually, I don't know how in lectures so which symbol do you use. So actually, it's good to know both of them. So the gradient is the vector of partial derivatives. And we will have to calculate this partial derivatives at point M. Actually, what does gradient mean? It is the direction of the fastest function increasing. So what does it mean? Okay, now let's calculate these derivatives. So the first partial derivative 3x cube by y cube by z. So and at point M it will be equal 3. Then calculating the partial derivative by y. So 2x cube y z, and it equals 2. Then du by dz at point M will be equal, so x cube y square, x cube y square, and it equals 1.
Sorry. Can
Yeah?
I ask a question? The partial derivative by dx, it's probably 6 because 3 by 2.
Y. So 1, 1, and 1 coordinates. So this point.
But derivative of x square is 2x, I
So
think.
x cube. So
Yeah, I see. Thank you.
okay. So now writing down the gradient of function u at point M. Stop. So it will be equal 3 to 1. So actually that's it. So quite simple task. For exercise B, it is even simpler. So no powers. Any questions about this exercise? Is everything clear?
Yes, because I thought that this is
Yeah.
not a derivative.
Ah, yeah, confusing a little bit. I agree. Okay. More questions? Okay, if no questions, let's move to the next task. So we will investigate the extremum of the function. So again, solving A, yeah, and 3B will be your home task. So z equals x cube, stop, x cube plus y cube minus 3xy. So we need to investigate this function, so extremum of this function. How to do it? For the function of one variable, you differentiate the function and then solve the equation when the derivative is equal to 0. Here we will do the analogical stuff. So we will differentiate this function by x and y, and then we will solve the system of equations when these derivatives are equal to 0. So the derivative equals 3x cube minus 3y, and it equals 0. So for this derivative, 3y square minus 3x, and again this equation equals 0. So yeah, so equation is the following, so 0 in the right part. Now let's simplify these equations. So we can divide by 3 both of them to simplify our calculations. Then let's do the substitution. So now y will be equal x squared. So x in power over 4 minus x equals 0. Then yeah, we have the so now let's factorize it. So x by x cube minus 1 equals 0. And we will have the following. So actually, we will have two solutions of this equation, of this system. Where is this opening bracket? Oh, here it is. So in the first case, so x, so x will be equal 0 and y equals 0 as well. In the second case, x equals 1, so y equals 1 as well. So we have two stationary points, M1 that has coordinates 0, 0, and M2 that has coordinates 1, 1. So stationary points, this is the points in which partial derivatives are equal to 0. So stationary point doesn't mean that we have extremum of the function. We need to investigate it more. So how to investigate? We have to find the second derivatives of this function. So the second derivative of z. So let's find first of all mixed derivatives. So it will be equal minus 3. And of course, let's find in another order. just to verify that first derivatives were found correctly. Yeah, and it will be equal -3 as well. Now, let's find clear derivatives. So we will differentiate this expression, and it will be equal 6x. Then the second derivative, clear derivative by y, will be equal. So if we differentiate this expression, we will receive 6y. So found the second derivatives, and now we have to calculate their values for both of these points. So what about point M1 with the coordinates 0, 0? So actually mixed derivatives at this point, yeah, so they are constant, but anyway, let's mention them. So let's write everything in details. So they will be equal -3. Then clear derivatives. So the second derivative by x, so will be equal 0. Yeah, and by the way, derivative by y will be equal to 0 as well. So let's write it in a more compact way. And now let's so we received the so okay, let me make the next metric, the following matrix. It will be the matrix of the quadratic form of the second differential. So we need to investigate if it is positively defined, negatively defined, or not sign defined. So if it is positively defined, we have the function of the local minimum, or we have a point of the local minimum. If negatively defined, it is the point of the local maximum. If it is not sign defined, it means that no extrema at that point. So let's use the Sylvester criteria. So delta 1 equals 0, and delta 2 equals 9. So it is greater than 0, but anyway, we have the first minor is equal to 0, so it means that M1 is not extremum point. Now doing analogical stuff to the point M2. So actually for mixed derivatives, yeah, will be analogical because they are constants, and for mixed derivatives, we will have different values. So, yeah, by the way, M2, yeah, let's change indices here, but we're not lost them. So, second clear derivatives, so both of them will be equal to 6. So 6 and 6. And we will have the following matrix. So 6 minus 3 and minus 3, 6. Yeah, now let's calculate this minus. So delta 1 is so equals 6 and it is greater than 0. What about delta 2? Delta 2 equals 36 plus 9, so it equals 45 and it is greater than 0. So we have positively defined quadratic form. So it means that M1, M2 is the point of minimum. And let's also calculate that at point M2. So it will be equal so 1 plus 1 minus 3, so it will be equal minus 1. So done with this task. Any questions about it?
Could you scroll up a bit to the first matrix?
Yeah. Oh, by the way, minus 9, sorry. Yeah, thank you for your attention. So less than 0 and here minus 9 as well. And by the way, we will have 27 that anyway is greater than 0. Yeah, that's good that we looked at it. So more questions?
No.
Anybody else?
Can
Okay.
you scroll down
Yeah, sure.
to the end?
Yes. So which question do you have here?
And I needed to finish writing.
Ah. Okay, if do you have to write a lot? I guess that not. Okay, let me know when you are done.
Yes, we can continue.
Okay, so this task is done. B will be for your homework. Here is the function of 3 variables. Actually, stuff is analogical, but you will have to perform more actions. But anyway, nothing strange for you. Just matrix is bigger. And now we will have to find the extremum of the following function. So we'll have to find the conditional extremum of the function. So what does it mean? So we have the function f from x and y that equals x x square plus y square, and under the condition x plus y minus 1 equals 0. So what does it mean? We have to find the extremum of the function at this straight line. So actually it could be a curve, but we have to find the extremum at this straight line. So how to do it? We will use a method of Lagrange multipliers, we have to set up the Lagrange function. So it will be the following. So so Lagrange function equals so sum of our function plus lambda multiplied by these conditions. So actually, yeah, so this is a Lagrange multiplier, this lambda. Now we have to differentiate this Lagrange function. So dl by dx okay, let's also set up the system of equations. So dl by dx equals 2x plus lambda. Then dl, yeah, and what about dl by dy? So it will be equal 2y plus lambda. And of course, it will have to equal 0. And also we have to differentiate by lambda. Here we just can copy and paste this condition. So found so found the first derivatives, and now let's solve this system. So what can we actually substitute? So x will be equal, yeah, let's express x and y via lambda. So x equals lambda over 2, or minus lambda over 2, by the way. And y will be equal minus lambda over 2 as well. And here we'll substitute x and y with this lambda. So minus lambda minus 1 equals 0. So let's find final solution. So lambda equals minus 1. Then x equals 1 over 2, and y equals 1 over 2 as well. So found. So actually the stationary point is the following. So point at which we have possible conditional extremum. So now we have to find the second derivatives. So, but we will have to differentiate only by x and y. So we don't have to calculate the derivatives, the second derivative by lambda. So only x and y variables care us. So it equals 2. Yeah, and actually, if I differentiate in another order, it will be stop. Yeah, it will even be equal 0. So yeah, so 0 if I differentiate by y, and 0 if I differentiate it by x. And what about clear derivatives? So 2 and d to l by dy twice equals 2. So now we have the following matrix. So 0, oh, stop. 2, 2, 0, 0. So what do we have now? Delta 1 equals 2, that's greater than 0. Then delta 2 equals 4, and that is greater than 0 as well. And what do we have? So, yeah, by the way, let me, yeah, yeah, what actually do we have to do? Yeah, we need to, yeah, we will have, yeah, yeah, here will be another way. So, of solution, yeah, we need to write down the second differential of a Lagrange function at that point. So D2L will be equal, yeah, at point M. Okay, let's write like this. So at and -1, so it will be equal to dx square plus dy square plus 2dy square. So, and yeah, also we can find, so from condition equation, we can find that dx equals minus dy, so it actually equals 4 dx square, and it equals 0. So, yeah, so it means that we have a point over the minimum. Yeah. So minimum point, and also let's calculate f at this point, 1 over 2, 1 over 2. So it will be equal, so 1 over 4 plus 1 over 4, it will be equal 1 over 2. So it's done. Any questions about this exercise?
No.
Okay, no questions. And now let's have a break for about 5 minutes, and then we will solve one more task with the usage of a function of multiple variables, with finding the largest and the smallest value of the function in a domain. And now have a break. Okay, let's continue. Yeah, I don't share my screen, so now I'm sharing my screen. So what do we have to do? So we have the following function. So polynomial function, and we have the following domain given by straight lines: x equals 0, y equals 0, and x plus y equals 6. So if we plot this domain, so we will receive such triangle. But we even can display it in a smarter way. So x equal greater than and equals than 0. Yeah, and y greater and equals than 0. Yeah, and actually it will be less than 6. Yeah, so we have the following domain. So this triangle. So how did we calculate the value of the function in so in the one-dimensional case? So calculating the largest and the smaller and the smallest values of the function on a segment. So you did the following task, performed the following actions. You calculated the derivative, checked if if you have the extrema of this function at the segment, and if you have, so you calculate value at this extrema, and also you have to calculate the value of this function on the edges of the segment. Actually, in the two-dimensional case, we will do the analogical stuff. So we will have to calculate the value of this function at the edges of the domain, and also we will have to investigate this function for extremum at this triangle. So let's start with, first of all, with edges. Yeah, and let's also mark some points here. So 0, 0. Let's mark it as O. Then 6, 6, 0. Let's label it as A. And also let's mark point 0, 6 that has coordinates. Okay, and let's name it as B with coordinates 0, 6. So let's yeah, let's mark them with another color. So what about the segment OA? So at this segment, so value of x, also no, value of y equals 0. So z equals 0 as well. Then what about OB? The same situation at this segment, x is equal to 0 and everywhere, so z will be equal 0. AB is much more interesting segment. So let's calculate it at OB. So let's express z as the function of one variable. So at this segment, it will be equal. Yeah. So by the way, here, yeah, let's express y where x. Y will be equal 6 minus x. So 6 minus x and multiplied by 2 minus x minus x plus 6. Let's also expand brackets. Yeah, let's simplify this expression. So x minus 6 by 8 minus 2x. So yeah, I also can move, for now I can move 2 out of brackets, by the way. So let's expand first of all these brackets. So x square minus, plus 6x and plus 4x. Yeah, so plus, plus 4x plus 6x. Yeah, plus 10x and minus 24. And now expand, so let's also multiply by x squared. So x in power of 4 plus 10x cube minus 24. And here we actually will do the analogical stuff as for function of one variable. So we will have to differentiate it. So that prime from x will be equal, so 2, and here 4x cube plus 30x square minus 48x. Yeah, and we have to find the zero value here. Well, we actually, yeah, so let's solve this equation. We
Sorry,
can
I have a
simplify it.
question.
Yes.
Why x square but not minus x square? X over x multiplied by minus x is x square.
Thank
Minus
you
x
for your attention. Yeah, minus x square. So minus here, and here. Yes, nice catch. Thanks. Yeah. So now let's continue. So yeah, we can simplify it a little bit. So it will be equal 0. And by the way, so let's, yeah, so we can move x out of brackets, by the way. So x by, so minus 2, minus 2x squared plus 15x minus 24. And by the way, we can actually, yes, find the solution here. Stop. Something seems to be incorrect. Yeah. So here was a mistake. So plus x. So let's rewrite it. Yeah. So confused the sign. So 6 minus x. And so minus y, so minus 6 plus x. So I will have just 8x squared by x minus 6. So now everything is correct. And also let's expand brackets. Or just I will move x square into the brackets, minus 6x squared. So now we can differentiate this expression. So 8 by 3x squared minus 12x. And let's move 3 out of brackets. So 24 by x squared minus 4x. So now everything is correct here. So now let's solve this equation. So x squared minus 4x equals 0. Then let's move x out of brackets. X by x minus 4 equals 0. So we know that when x equals 0, value of z equals 0 as well. So it's not interesting for us. But what is really interesting for us is point x equals 4. So yeah, let me check here. Yeah, so correct. So when x equals 4, yeah, we have the point M. So with the 4 and so 6 minus x, 4 and 2 coordinates. And let's check here. So 4, 2. So x equals, yeah, so point M. So 4, 2. So it is on the bounds of the domain. So it seems that everything is found correctly. So now let's calculate the value of this function at point M. So 4 square, okay, 16 by 16 by 2 and by so 2 minus 4 minus 2. So 32 multiplied by minus 4, it will be equal minus 128. So calculated, so found all interesting for us values at the edges of the region. And now let's try to find extremum inside this region. So calculating partial derivatives. So dz by dx will be equal, yeah, by the way, let's expand it. So x, yeah, so 2x square y minus x cube y and minus x cube y cube, x square y square. So let's differentiate. 4x y minus 3x square y minus 2x y square. So found. And now analogically to y, two x square minus x cube minus 2x square y. Okay, and now let's solve this system. So system of these equations. So equals 0, and this equation equals 0 as well. So let's simplify something a little bit. So here I can move xy out of brackets. So xy here 4 minus 3x minus 2y. And here I can move x square out of brackets. X square by 2 minus x minus 2y equals 0. Now I will also divide by x square by xy because we mean that both of them of these variables they are not equal to 0, because we know that we know the behavior in at point 0, 0, so it is not interesting for us. Okay, let me check if also what I have here. So stop. Yeah, so 4 minus 3x minus 3y. Okay, let me check y minus 3y. Yeah. Stop. Minus 3x, y minus 3y. Okay, let's see. So x square, so 2x square y minus x cube y minus x square y square. Okay. And here. Okay, let's check these derivatives. Here is a mistake. Yes. So let's okay, now let's solve this system of linear algebraic equations. So let's move 3 members to the right side. No, stop. It will be equal 4. And here we will do the same. So x plus 2y equals 2. Yeah, it's quite a simple system. So we can solve it without heavy artillery, like, yeah, actually, so we will use the Gaussian method. So we will subtract the first equation from the second equation from the first. So what we will receive? So 2x equals 2, and so 2y equals 2 minus x. So, stop, 2 minus x, yeah. Then, so x equals 2. And y will be equal, so, yeah, x equals 1, sorry, and y will be equal 1 over 2. Yes. So now we have to calculate values of z at such point. So, okay, what we call this point n. So 1 and 1 over 2, and let's also verify that it is inside the region. Yeah, and it is really inside the region. Actually, it's not, so it doesn't matter now for us. We don't have to investigate if it is extremum point or not extremum point. We just need to calculate. So the value of the function at this stationary point. And we don't absolutely care if it is a local minimum or local maximum. Absolutely, it's not important for us. Now we just will calculate value and compare with other values. So 1 multiplied by 1 over 2 and 2 minus 1 minus 1 over 2. So it will be equal, okay, so 1 minus 1 over 2, yeah, 1 over 4. So 1 minus 1 over 2, yeah, so correct, 1 over 4. And now, so what do we, so now let's compare our values all values that we received. So we received z equals 0 at these edges. On this edge, we have value minus 128, and it is actually the minimum value, so the least value. And the largest value seems to be 1 over 4. So the final answer will be the following. So z minimum equals minus 128, and z with index maximum equals 1 over 4. So this is the final answer, how it must be written. Any questions about this exercise, about the whole lesson, about previous lessons? Stanislav, yeah?
Haven't you checked our individual tasks yet?
Currently, I am in progress. Yeah, I have started checking individual tasks. You will be notified. So I have started checking your individual tasks, and I guess by the end of the next week, I will be done with it. Maybe even a little bit earlier. And yeah, by the way, I wanted to tell you about individual tasks that please pay attention to comments that I write to you and check your individual tasks. So in some cases, as I saw, you calculate integrals in a more complicated way that you could. So please pay attention to them and just to simplify your calculations.
And I have another question.
Yeah.
On VL, in attendance, it says that we had practical lesson 8 yesterday for some reason, even though it wasn't on schedule.
Okay, maybe, yeah, it was my mistake. Yeah, so yesterday. Okay, let me check. So by the way, it's group number 2. So okay. But by the way, could you mark your attendance today?
Yes.
Yeah. So I just
It was
confused.
on
Yeah.
practical lesson 9.
Yeah. So I just so it was mistake with the topics. So everything is fine. Yeah. So just copy and paste mistake. Okay. More questions?
No.
Okay, if no questions, let's finish. So have a nice day. Stay safe. Thank you for your attention. Goodbye.
Thank you. Goodbye.
Okay, goodbye. Bye.
Have a nice day. Goodbye.